So today I'm going to show you 3 questions from Simon's favorite factoring trick. Maybe you could call that 4 because my first question is, who is Simon? Uh, for me, the answer to that question is I have no idea who Simon is, but I know Simon has a favorite factoring trick, which I'll be showing you today. So let's start with a simple one. We have mn plus m plus n is equal to 76. And we have to find all positive pairs of integers m and m so that um if we put this in here, it would work. You can't just go around like 1 and 2, 2 and 3, just that won't work. You have to find positive two positive integer pairs of m and m, of m and n, not the candy, such that it would fit into this equation. So first let's factor out m on the left side. So we have m times n plus 1 plus n, which is equal to 76. We can't just leave it like this. We have to factor the n too. So if we add 1 to both sides, we get m times n plus 1 plus n plus 1, which is equal to 77. So we can turn it into m times n plus 1 plus n plus 1, which is equal to 77. And then now change it up a little more. Plus 1 times n plus 1, which is equal to n plus 1, since that's common over here and over here, it's common, so you can take that out, times n plus 1, because that's what we're multiplying both of them with, which is equal to 77 times 1. Now we have to factor 77, so we have something to um so we have an idea what these could be, and m with what we have, so that we we can find positive pairs. So since it's positive, I'm going to stick with positive numbers, no negatives, because then we have to go into negative, which won't work for this question. So let's let's start with this one. So it could be like it's n plus 1 is equal to 77, and m plus 1 is equal to 1. But this wouldn't work because then m would have to be 0, and it says positive pairs, and 0 is neither negative nor positive. It's right in the middle. So we know that this pair will not work. So then let's try the other way around. N plus 1 is equal to 1, and m plus 1 is equal to 77. Still won't work because n plus 1 is equal to 1, then n would have to be 0. So this won't work either. So we know that neither options from this would work. So now we have to work with this. N plus 1 is equal to 11, and n plus 1 is equal to 7. That would work. Or n plus 1 is equal to 7, and n plus 1 is equal to, right, let's turn this into 11, and this would be 7. So we have these two pairs of positive integers m and n that would work. So let's try the second question. It's also pretty easy. We have BC minus 7B plus 3C is equal to 70. So this time, unlike the one before, we have to find all pairs of B and C, all pairs of integers B and C that would satisfy this equation. But this time, it doesn't say we have to do positive. We have to do any integers. It doesn't matter positive or negative. We have to find all pairs, positive and negative. So let's get started. So we'd like to factor the left side, like we did before, like this: b plus something times c plus something is equal to whatever is on this side. So so let's get started. We can factor this by doing b plus 3 times c minus 7. So that if we multiply b and c, we get bc. If we multiply b and negative 7, we get negative 7b. If we multiply 3 and c, we get 3c. But if we multiply 3 and negative 7, we get minus 21. Since we don't have it over here, we can turn this into BC minus 7B plus 3C minus 21 is equal to 70 minus 21. So now we have B plus 3 times C minus 7 is equal to 49 times 1. As we did before, we have to factor out 49. We have 49 times 1. We have 7 times 7. Or we could do negative 1 times negative 49. Or we could do negative 7 times negative 7. Okay, so now let's write down all of the pairs. We could do b plus 3 is equal to 49, and c minus 7 is equal to 1. So that's one pair. But we could also do b plus 3 is equal to 1. It doesn't matter now that b is negative 2, because it says all pairs, not all positive pairs, or it doesn't, and it doesn't even say all negative pairs. So any integer pairs. And we have c minus 7 is equal to 49. That's the second pair. Alright, so b plus 3 is equal to 7, and c minus 7 is equal to 7. That's another pair. We can't flip this around, because 7 and 7, they're obviously the same numbers. So now we have b plus 3 is equal to -1, and c minus 7 is equal to -49. That's our fourth pair. B, and we have b plus 3 is equal to -7, and c minus 7 is also equal to -7. That's our fifth pair, but we're forgetting something. B plus 3 is equal to -49, and c minus 7 is equal to -1. So that's our sixth pair. And these are all the pairs we have. Good luck finding all of these with trial and error. So now we have a very freaky looking question, which is how many ordered pairs mn of positive integers are solutions to 4 by n plus 2 by n is equal to 1. Okay, I do agree with anyone who thinks that this question is freaky looking. So before we go into any solving or anything like that, let's turn this into not freaky looking question. So let's start by multiplying both sides by mn. We get 2m plus 4n is equal to mn. So as we did in the other questions, we're going to take all of the unknown values to one side, which gives us mn minus 2m minus 4n is equal to 0. So now let's factor this side out. We can turn this into m minus 4 times n minus 2. So then when we multiply m and n, we get mn. When we multiply m and -2, we get -2m. When we multiply -4 and n, we get -4n. But when we multiply -4 and -2, we get 8. So since all of this is equal to 0, we have to add 8 to both sides since we have -4 times -2. So this would be equal to 8. And as we did before, we're going to factor 8. 8 times 1, which is equal to 4 times 2. Nothing negative because question 3, like question 1, says we have to find all ordered pairs of mn which are positive. So we can't go into anything negative. So let's write all the possibilities. M minus 4 is equal to 8, and n minus 2 is equal to 1. Okay, that works. So that would be our first pair. Second pair is m minus 4 is equal to 1, and n minus 2 is equal to 8. That also works. Let's start on our third pair. So we have this done. Now let's start on to this one. M minus 4 is equal to 4, and n minus 2 is equal to 2. Yes, that works. And last one, m minus 4 is equal to 2, and n minus 2 is equal to 4. That is our fourth pair. So that's all for Simon's favorite factoring trick. Again, I told you I do I do not have any idea who Simon is.